time to do some adding and subtracting. A lot of people do not like to do this video. People think, I know how to add and subtract. Why should I watch a video on adding and subtracting? The truth is, a lot of people make such tiny little mistakes when it comes to adding and subtracting, and it affects their score, because if you make a mistake in one step that you add or subtract, you get the entire question wrong. So that is why I took the time to make this video for you, to go over the mistakes that people make, to make sure that you learn how to avoid them. So just hang tight, it's a quick video. I'm going to go over a couple of things, and then you can go ahead and do that arithmetic drill I know you're dying to do, so you can practice your skills and make sure that you're really great at adding and subtracting. Remember, we're working towards a high score on the ASVAB, and we're going to do whatever it takes. So let's do this. So we're going to start off with the first one, which is 605 plus 224. First common mistake that people do is that they don't want to add by stacking them or rewriting the question. They want to just do like 6 and 2 and like 0 and 2, and they think that they're going to get the answer correct like that. Sometimes it really is worth rewriting the question. I mean, to me, it's worth it to rewrite the question if it means that I have a higher chance of getting it right, because my goal is to get as many questions right as possible on that test, right? So I rewrote it, I stacked it. You see that the numbers are lined up, so I know exactly what is being added to what. I'm not going to confuse anything. And I'm going to do 5 plus 4 is 9, 0 plus 2 is 2, and 6 plus 2 is 8. Really easy, really straightforward. We don't have to carry anything here. Let's look at the next one. Once again, I'm putting it one above the other because I want to make sure that we get this question right. So I stack them up. 8 plus 8, 16. I put that 6, carry a 1. Super important. I know you guys know how to carry numbers, but a lot of you guys might not write the number that you're carrying, and you want to hold it in your head. You got a lot going on in your head. You're thinking about how you need to pass this test. You're thinking about what job you want to get when you get into the military. You're thinking about things going on at home. You do not have space in your head to keep that 1 in there. So put it down on paper. Don't add more things to your head that you don't need. So put down that 1 when you carry it. 1 plus 7 is 8. 3 plus 0 is 3. Our answer is 386. Okay? So far, so good. Let's do one more of these and make sure that we have mastered the skill. So 415 plus 997. Okay, I stack those things up. 5 plus 7 is 12. I'm putting that 2, carrying the 1. 1 plus 1 is 2. 2 plus 9 is 11. I'm going to put the 1. Guess what? I have to carry again. Am I going to keep that number in my head? No, I have things to think about. So I'm going to carry that 1, and I'm going to write it so I don't forget it. 1 plus 4 is 5. 5 plus 9 is 14. So I'm going to do 14,412. Okay? Okay, great. Now that we've looked at adding, let's look at a couple of subtraction problems. And let's make sure that we understand what to do in what situations. So we're going to start off with an easy one. Super straightforward. We're going to stack it because we want to make sure we get things right. 7 minus 6 is 1. 0 minus 0 is just 0. And 3 minus 2 is 1. Real easy, real straightforward. If we have a 0 and a 0, remember it's still 0. Okay? Everything's stacked up. Awesome. Let's try something a little more difficult, shall we? 635 minus 228. A common mistake that people make when subtracting something like this is they see that the number 8 is bigger. So they're like, okay, I'm just going to do 8 minus 5 is 3. Wrong. Please don't do that. I know it seems like the right thing to do, but it's actually not. This is incorrect. What you need to do instead is you need to borrow, because we're still doing the top minus the bottom, okay? So if 5 is too small to subtract 8 from it, we're going to borrow from 5's neighbor, and 5's neighbor is 3. So when we borrow, we're going to cross out the number and write the new number that it becomes. We're taking away 1, so now this 3 becomes a 2. And when we take away 1, we add it to the front of the 5, so the 5 becomes 15, okay? So why did I rewrite it? Once again, I have things on my mind. I'm worried about other stuff. I cannot be bothered to hold some number in my head. So I'm going to do 15 minus 8 now is 7. 2 minus 2 is 0, and 6 minus 2 is 4. Everything's looking good. We're feeling good about subtraction. We're not making small mistakes, okay? Let's do the next one. 300 minus 199. So 300 minus 199. Okay, remember, we cannot do 9 minus 0 because we know that's wrong now. We know that we have to do the top minus the bottom. So it is 0 minus 9. We have to borrow from the neighbor. But guess what? The neighbor has nothing for us to borrow. Their fridge is empty too. So we have to go to the next neighbor. And that next neighbor is 3. We're only going to borrow 1 from it. So this becomes a 2. And since we borrowed 1, we're going to put it in front of the 0. But it goes to this neighbor, not the other one. But we still need something for the last neighbor, right? So we're going to borrow from this 10. This becomes a 9. And now this one becomes a 10. Okay? So one more time. When we borrowed from the 3, it became a 2. And my first 0 here became a 10. But I go back to my original one that I'm trying to subtract first, and I realize I still need to borrow. So I go to the neighbor who now has 10, and I borrow 1 from him, which makes him a 9, and makes this last one, a 10. So now that everybody's all borrowed and set up, and I have everything written at the top, and I'm not trying to remember numbers, now I can subtract. So 10 minus 9 is 1, 9 minus 9 is 0, and 2 minus 1 is 1. So my answer is 101. I hope these examples were helpful. I hope they show you what mistakes that you could be making and how to not make them anymore. Please make sure to do that wonderful arithmetic addition and subtraction drill at the end of this video. You'll see it right below. It's going to help you with your time. Remember, you only have 75 seconds to answer a question. So the faster you are in little steps like adding, subtracting, multiplying, whatever it is, the better you're going to do on the test. All right? So good luck. I'll see you in the next video. Okay, so I'm doing this quick video to show you how to borrow when you have so many zeros like this. And this is per request of someone that was trying to do it and got a little confused with it. So, because this is a common question, I just want to make the video for everyone to see, just in case this is something that also confused you, okay? So, when I'm looking at this, I say, first of all, I can't do 4 minus 6. I'm starting on this side over here. I can't do 4 minus 6 because 6 is bigger than 4. So I have to borrow from the neighbor. But the neighbor has nothing to give me. So this neighbor goes to the next one, which also has nothing. And the next one, which also has nothing. So we get to this neighbor. This is a neighbor we can finally borrow from. So I borrow from here. I get a 0. When I borrow, I give to this neighbor right here. Okay, this one becomes 10. And to give to its neighbor, we cross this one out. This one becomes a 9. I take away 1 from it. So this one can also become a 10. for this neighbor to borrow right here, this one has to become a 9 as well, so this neighbor can become a 10. Okay, so I'm borrowing and letting all the other neighbors have. And then this one needs to borrow, so this one becomes a 9, and this one becomes 14. So I do 14 minus 6 is 8, 9 minus 9 is 0, 9 minus 9 is 0, 9 minus 8 is 1. So the answer is 1008. Okay, now I realize this one is kind of exceptional because it has a lot of zeros, so let's try something that's a little bit smaller. So let's try 1004 minus 899. So let's see it again in action. I can't do 4 minus 9, so I'm going to come borrow from here. But I can't, and I can't, but I can make this a 0, and now this becomes a 10. Now that this becomes a 10, to borrow, it becomes a 9, so this one can become a 10. And for the next one to borrow, this one becomes a 9, and this one becomes 14. So 14 minus 9 is 5, 9 minus 9 is 0, and 9 minus 8 is 1. So I get 105, okay? I hope that helped. Give it a try if you want to go back and maybe try these on your own and then watch the explanation again so you can see where you're making mistakes. That could be something helpful. If not, just leave me a comment a reply in the comments below, and I'll be more than happy to help you. It is time to multiply and divide. I cannot tell you how many people struggle with multiplication and division. What we're going to go over today is a couple of instructions on the most common mistakes people make when multiplying and dividing. I want to go over these things with you because you know what? A lot of people are so used to using calculators, especially now that we have calculators on our phones, and we forget the basic things like multiplying and dividing. I am sorry. Okay, so the point is this. Multiplying and dividing well, quickly, always getting it right, doing it good every single time you do it, is so important to the small steps in all the math sections on the ASVAB, okay? People who struggle with multiplying and dividing sometimes get them wrong or too slow when doing it. They're the ones that struggle the most, and they're the ones that score lower on the ASVAB. But you are working on scoring high on the ASVAB. So the first recommendation I'm going to make to you before I even start going over the lesson completely is that you take some time, take a couple days to write out your multiplication tables. So just do like 2 times 1 equals 2. 2 times 2 equals 4. 2 times 3 equals 6. 2 times 4 equals 8. I know it doesn't sound like fun. I know you don't want to do it. But people who do this always improve their multiplication, always improve their score. And why is multiplication so important? Because being able to multiply well affects whether or not you can multiply and divide, okay? So make sure you take the time to do that. If you're working right now and your schedule's a little hectic, then take a little notebook, have it in your pocket, one of those little notebooks you can get like at the dollar store or something, I don't know. But whenever you have a little bit of downtime, you take that little notebook out and you keep writing your multiplication tables. You do that for a couple days, 3, 5 days, you're going to be amazing. You're going to do so good and your multiplying is going to improve dramatically. All right, so now that we've talked about that, let's get into multiplying larger numbers, okay? Once again, most common mistake people make, they try to multiply in their head or they don't line things up. Stack these up once again so you can multiply well, okay? First one, we're going to do 6 times 8, okay? We always do the first times the first. So 6 times 8 is 48. I write down the 8, I carry the 4. Are we going to try to keep a number in our head? No, we're not. We have a lot on our mind, right? You have a lot on your mind, I have a lot on my mind. So I'm going to write down that number right there, okay? 6 times 4 is 24. I'm going to add the 4 now. 24 plus 4 is 28. So our answer here is 288. Beautiful. Now that we've done this first one, let's go to the second one. Looks a little more complicated because now we have 2 numbers down here. So 62 times 34. So we start with this first one and we multiply it over here, okay? So 4 times 2 is 8. And 4 times 6, now we multiply over here, is 24. Now, to be able to move on to the 3, we're going to have to put a 0. Some people like to just leave a space. I like to leave a 0 because sometimes if you don't leave a 0, your numbers get all like weird and stuff. You don't want that. You don't want confusion. You're trying to score high on the ASVAB. So just to be certain, I recommend you add a 0. So now that we've added the 0, now we can multiply it by 3. So 3 times 2 is 6. 3 times 6 is 18. Okay? Now that we finished multiplying everything here, we're going to add. So 8 plus 0 is 8. 4 plus 6 is 10. I'm going to put that 0, carry the 1. 1 plus 2 is 3. 3 plus 8 is 11. Put the 1, carry the 1. 1 plus 1 is 2. My answer is 2,108. Okay, I hope you got that. Don't worry, you're going to get a chance to practice this in the math quiz that's underneath this video, okay? Let's do one more, just to make sure you understand, okay? We're going to do 106 times 28. So we start off with 8. 8 times 6 is 48. We put the 8, carry a 4. 8 times 0 is 0. 0 plus 4 is 4. Now we move on. 8 times 1 is 8. Now that we've done that, we put our placeholder 0 to make sure things line up nicely. And we're going to do 2 times 6 is 12. Oh, sorry. 2 times 6 is 12. Now I have to carry a 1. I'm going to cross out this 4. And I'm going to put a 1 above it. Why am I going to cross out the 4? I'm crossing out the 4 so I don't get it confused and add a 4. I want to make sure that I add the 1 that belongs there. You don't know how many people make that mistake. I just want you to avoid it, okay? So 2 times 0 is 0, plus that 1 is 1. And 2 times 1 is 2. Now that we've done that, we're going to add these beautiful numbers together. 8 plus 0 is 8. 4 plus 2 is 6. 8 plus 1 is 9. And 0 plus 2 is 2. That's it. We are done, okay? Everything's looking good. We have just multiplied, and we did a great job at it. Now on to division. So many people struggle with division. And I get it. It's not easy. So I really want to go over it with you because I really want you to do well. So I'm going to set it up first. 3 on the outside, 348 on the inside. So we're going to divide into that first number. 3 divided by 3. Okay? 3 divided by 3 is 1. 3, well, now we times it. Okay, we're going to multiply it. 3 times 1 is 3. So I'm going to put the product down here, and I'm going to subtract them. 3 minus 3 is 0. Now I'm going to bring down a 4. And I'm going to say 3 goes into 4, or 4 divided by 3. But 3 goes into 4 one time. 3 times 1 is 3, so I multiply. Remember, there's like a little multiplication sign there. 3 times 1 is 3. 4 minus 3 is 1. So now that I've done that, I bring down an 8. A lot of people don't like to put the arrows. I like to put the arrows because, once again, we've got a lot on our minds. We might forget to bring down a number. Or we might forget that we already brought down that number. So to make sure we don't get anything confused, we bring down an arrow every single time we bring a number down. So now 3 goes into 18 exactly 6 times. So 3 times 6 is 18. And 18 minus 18, boom, is 0. Okay, our answer is 116. Isn't that beautiful? Okay, let's try it again, but this time with 8. So 8 goes into 204. Now this time, 8 is too big and it cannot go into 2. So we're going to do 8 goes into 20. Well, how many times does 8 go into 20? 8 times 2 is 16. And 8 times 3 is 24. Now 24 is way too big, so we're going to stick with 2. 8 times 2 is 16. So we're going to put 16 down here. We subtract it and we get 4. Now we can bring down our 4. 8 goes into 44. It doesn't do it evenly. 8 times 5 is 40. That's really close. 8 times 6 is 48. That's way too big, so we're not going to use 6. We're going to use 5. So we put a 5 up here, and we multiply. 8 times 5 is 40. And we're going to subtract. Well, we have a remainder. What are we going to do now? Let's turn this into a decimal. So we're going to add decimal, 0. And if we added a decimal here, we have to add a decimal here as well. Okay? One more time. We added a decimal here, so we're going to add it up here as well. Now we can add a 0, and we can bring down that 0. And this becomes 40. 8 goes into 40 5 times. Exactly. 8 times 5 is 40, and 40 minus 40 is 0. So our answer is 25.5. Great number. Okay? Now I know turning these into decimals is a little confusing, so just to make sure you get it, I want to do one more with you. So 4 goes into 8, 2 times exactly. 4 times 2, 8. 8 minus 8, 0. Let's bring down that 3. 4 goes into 3. It cannot. 3 is too small. So what do? We do a 0. 4 goes into 3, 0 times. We have to put a 0 here. If we don't put a 0, you're going to get it wrong. So let's put a 0. Now 4 times 0 is 0. 3 minus 0 is 3. Now we can bring down a 2. 4 goes into 32, 8 times exactly. So 4 times 8, 32. 32 minus 32, 0. All right. We are all done. I know this is just a few examples, but it's to give you an idea of how to do this. Make sure you do those multiplication tables to help you get faster and better at doing your multiplication. And make sure to do the drills at the end of this lesson. So as soon as you finish this video, you'll see the quiz right below. Remember to check our frequently asked questions, and if you have any questions, just submit it in the form that's included on this lesson. Okay, good luck. These 3 digits, all we're doing is adding another 0 when we add a new row, okay? So I'm going to do this one to kind of show you what that looks like, and then I'll give you another example as well, now that you can practice it. So we start always on the right. We start with 4. So 4 times 4 is 16. I carry the 1. 4 times 6 is 24, plus 1 is 25. Carry the 2. 4 times 9 is 36, plus 2 is 38. Now, to start a new row, I put a placeholder 0. And now I do this new row. I'm going to cross these out. 0 times 4 is 0. 0 times 6 0. 0 times 9 0. Now to start another new row, instead of just putting 1 0, I have to put 2 zeros. And now I can do it. 2 times 4 is 8. 2 times 6 is 12. I carry the 1. 2 times 9 is 18, plus 1 is 19. Now I add these all up. 6 plus 0 plus 0 is 6. 5 plus 0 plus 0 is 5. 8 plus 0 plus 8 is 16. I carry 1. 1 plus 3, 4. Plus 2 is 6. 9 and 1. Okay, so my answer is 196,656. So the key here is very simple. All you have to do is add a new 0. So like the second row gets 1 0. The third row gets 2 zeros. If we were to add a fourth row, it would get 3 zeros. Okay, let's do one more. So let's do 368 times 917. The reason I want to do another one is because this one has a 0 in it, so it might be a little misleading. So I want you to see one that doesn't have 0 in it. This is a good time to hit pause on this video and give this question a try before you see me work out, okay? So if you want, hit pause, and when you're ready, just come back and take a look at the explanation. So 7 times 8 is 56, carry the 5. 7 times 6 is 42, plus 5 is 47, carry the 4. 7 times 3 is 21, plus 4 is 25. So we're done with that first row. Next one, I put 1 placeholder 0. 1 times 8 is 8. 1 times 6 is 6. 1 times 3 is 3. Now I want to start the next one. I put 2 placeholder zeros. Notice I'm being careful about the way I align things, and that way it's easier to add them up later on. So, pay attention to that. 9 times 8, 72. I put a 2. I carry a 7. 9 times 6 is 54. Plus 7 is 61. Carry the 6. 9 times 3 is 27. Plus 6 is 33. Now I add things up. 6, 15, carry the 1. 1 plus 5 is 6. Plus 6 is 12. Plus 2 is 14. Carry the 1. 1 plus 2 is 3. Plus 3 is 6. Plus 1 is 7. And then 3 and 3. So 368 times 917 gives me 337,456. Okay? All right, I hope you got that. If not, just let me know. Leave a comment below, and I'll be more than happy to help. So now that we're moving on to operations with fractions, there are a couple of things that you should know. there are specific rules that apply to operations in the terms of like addition and subtraction. So there are certain rules for addition and subtraction, and there's a different rule for multiplication, and there's a different rule for division. So we're going to start off with the rules for addition and subtraction with fractions, and remember they're the same. So when we're adding and subtracting fractions, we need to make sure that the denominator is the same. The denominator is the bottom number. Okay. So here, let's try a different color, just so it's easy to differentiate. Here we have a 9 and a 16. These are different. Once we have the denominators the same, we can add them. So like let's say we have 1/3 plus 1/3. Because the denominators are the same, we can add them. And when we add them, we keep the denominator the same, and we just add the numerators, or the number on top. 1 plus 1 is 2, okay? Here, in this example, they're not the same. So what do? Well, we multiply them by each other, okay? So this side, we're going to multiply by 16. And whatever we do to the bottom, we have to do to the top as well. And this side, we're going to multiply by 9. Okay? So let's do 16 times 9. I'm going to do the math over here so we can take a look at it to make it easy to see. 9 times 6 is 54. We're going to carry the 5. 9 times 1 is 9, plus 5 is 144. So that's going to be our denominator over here. 16 times 5. 5 times 6 is 30. We put the 0, we carry the 3. 5 times 1 is 5, plus 3 is 8. So we end up with 80 over 144. Plus, we know here 16 times 9 is 144. And now let's do 13 times 9, so we can get the numerator for this one. So 9 times 3 is 27. We carry the 2. 9 times 1 is 9, plus 2 is 11. So we have 117. Now remember, when we're adding them, the denominator stays the same, right? 144, 144, 144. And what we're doing is we're adding the number on the top, the numerator. So we're going to do 117 plus 80. And that gives me, 7 plus 0 is 7. 1 plus 8 is 9. 1 plus 0 is 1. 197 over 144. Now let's notice something. The numerator here is bigger than the denominator, okay? Which means this is actually an improper fraction, which we have to turn into a mixed number. We're going to review that a little bit later. We're not going to worry about that now. We're just going to leave it at 197 over 144. Okay? So let's go ahead and move on. Go ahead and give this one a try on your own. Remember, we're making the denominators the same by multiplying them by each other. I'm going to give you a second to try it out, and then I'll go over it with you. Okay, here we go. So like I told you, we want to make the denominators the same. So we're going to multiply by the same number on the top and the bottom. So 17 on this side, 13 on this side. Like I said, same number top and bottom. We're working with bigger numbers, but that's okay. That gets us to practice with more complicated things. So let's figure out what our denominator is going to be. So 17 times 13. 3 times 7 is 21. So we're going to put a 1 and carry the 2. 3 times 1 is 3, plus 2 is 5. We're going to put that placement 0. 1 times 7 is 7. 1 times 1 is 1. So now let's add these together. 1, 5 plus 7 is 12. Carry the 1. 1 plus 1 is 2. 221. That is my denominator. Okay, perfect. Now let's do 17 times 8. So 8 times 7 is 56. So I'm going to put a 6 and carry the 5. 8 times 1 is 8, plus 5 is 13. So I have 136 up here, 221 on the bottom. We're going to do 221 here again. And we're going to do 13 times 3. To get the numerator on the second fraction, 3 times 3 is 9. 3 times 1 is 3. So 13 times 3 is 39. So now we're going to add these together. Remember, the numerator stays the same. We're going to do 136 plus 39, so we can figure out what the numerator is. 6 plus 9 is 15, so we carry a 1. 3 plus 3 is 6, plus 1 is 7. We end up with 175. All right. Now let's take a look at the same thing, but this time we're looking at subtraction. So we're going to make the denominators the same, and then we're going to subtract the numbers. I want you to give this one a try before I go over it with you. I know we haven't done subtraction before, but because it's the same rules, I want you to give it a try anyway. Okay? I'll give you a second, and then I'll go over it with you. Okay, perfect. Here we go. So we're going to do this side times 9, this side times 7. And whatever we do to the bottom, we're also going to do to the top. So 9 times 7 is 63. Sorry about that. 9 times 3 is 27. 1 times 7 is 7. 9 times 7 is 63. So we have 27 minus 7, which gives us 20 over 63. Okay? All right, that's our answer. Can we simplify it? Doesn't look like it. I'm going to move on. We'll have a couple other ones we can simplify that we can practice that together with. Go ahead and give this question a try before I show you how to do it. Go ahead. So I hope you got it. If not, don't worry. I'll go ahead and explain it to you now. If you have to hit pause, maybe rewind and look at it again and just kind of figure out at what step you went wrong. But here we go. I'll show you how to do this. So we're doing 8 on this side. Oh, sorry, no. 8 on this side, top and bottom. 5 on this side, top and bottom. Because if we multiply them by each other, we get the same denominator. 8 times 2 is 16 over 8 times 5 is 40. Minus 1 times 5 is 5. And 8 times 5 is 40. So now we're going to keep the denominator the same, and we're going to subtract the numerator. The numerator is 16 minus 5, which gives us 11 over 40. 11 is a prime number, which means it cannot be divided by any number aside from 1 in itself. So we cannot simplify this any further. Therefore, our final answer is 11 over 40. Now that we've done that, let's go ahead and take a look at the multiplication rules. So multiplication rules are pretty simple. You're just going to multiply straight across. Let's zoom this in a little bit. So 2 times 3 is 6. 9 times 16, we do got to do on the side here. It's not as obvious. 9 times 6 is 54. We put the 4 and we carry the 5. 9 times 1 is 9, plus 5 is 14. So that's 6 over 144. Now this number can be simplified. We could divide both the top and the bottom by 2. So let's give that a try. 6 divided by 2 is 3, and 144 divided by 2. Once again, not so obvious, so let's go ahead and work it out. 2 goes into 14 7 times. 2 times 7 is 14. 14 minus 14 is 0. We're going to bring down that 4. 2 goes into 4 2 times. 4 minus 4 is 0. So 3 over 72. Now, can we simplify this further? As a matter of fact, we can. I'm going to show you a little trick. Here, we know 3 can be divided by 3. It can be divided by itself. And 72 can also be divided by 3. Well, how do I know that off the top of my head? It's not because I'm a math genius. I just know a little trick. If we look at a number, 72, for example, in this case here, we can tell if it can be divided by 3 by taking the numbers 7 and 2 and adding them to each other. And we get the sum. If the sum can be divided by 3, then the number 72 can be divided by 3. So let me give you another example of this. 144 equals 1 plus 4 plus 4. I'm looking at the sum of all the numbers in this digit. 1 plus 4 plus 4 is 9. Can 9 be divided by 3? Yes, it can, which means 144 can be divided by 3. Does that make sense? I hope so. So, with that said, let's do 72 divided by 3. Let's divide 3 top and bottom. 3 divided by 3 is 1. Let's put some equal signs here. But we're going to do 3 into 72 because that one's not as obvious either. 3 goes into 7 2 times. 3 times 2 is 6. Bring down the 2. 3 goes into 12 4 times. 12 minus 12 is 0. So that means that this is, oops, sorry about that. This is 24. This is the answer to this. Okay? Now, that took us a little bit longer because we had quite a bit of simplification to do here. And I also showed you a trick with 3's, so we can see how we can tell if a number can be divided by 3 or not. So don't get discouraged. Not all these questions are going to take you this long. Let's take a look at another one. Okay? So next one, 7 twelfths times 3 14ths. I'm going to go over, actually, I'm going to let you do this one on your own. Give this one a try. I'm going to do that for you. Give this one a try, and I will come back and show you how to do it. All right, good. Go ahead and good luck. Okay, so let me go over this one with you. Remember, we're not giving them the same denominators. We're just multiplying across. So we're going to do 7 times 3 over 12 times 14. Okay? 7 times 3 is 21. 12 times 14, we're going to work up here on the side because that one's a little more complicated. 4 times 2 is 8. 4 times 1 is 4. 1 times 2 is 2. 1 times 1 is 1. 8 plus 0 is 8. 4 plus 2 is 6. 1 plus 0 is 168. So it's 21 over 168. I got those numbers confused. Now, can we divide the top and the bottom by a number? Because we need to simplify this, right? 21 over 168. I'm going to put it down here so it's easier to see. Well, yes, we can divide by 3. 2 plus 1 is 3, which can be divided by 3. And 1 plus 6 is 7 plus 8 is 15, and 15 can be divided by 3. Remember the rule of 3 I taught you. So let's go ahead and divide both of these numbers by 3. 21 divided by 3 is 7. And 168 divided by 3, I'm going to do over here. I'm going to do it a little lower so we have space to work. So 3 goes into 16 5 times. 3 times 5 is 15, which gives me a remainder of 1. I bring down the 8. 3 goes into 18 6 times. So I end up with, 7 over 56. Now, can I simplify this further? Yes, I can. I can actually divide by 7 top and bottom. Because 7 can be divided by 7, and 56 can be divided by 7. So 7 divided by 7 is 1. 56 divided by 7 is 8. So my answer to number 6 is 1 over 8. All right, I hope you got that. I hope that was straightforward enough. We're going to move forward to division. If there was something you didn't understand in multiplying fractions, I encourage you to go back, rewind, and kind of see what you didn't get, okay? All right, let's look at division. So division is a little bit different. It has its own set of rules. Some people like to cross-multiply with division. I don't recommend that you cross-multiply with division because sometimes people cross-multiply and they get confused. So I'm going to show you a way that you're going to always get it right and you're going to avoid confusion always, okay? So first things first. Let's simplify this number. 9 over 12. I want us to work with small numbers. The small numbers help us to do less work in the long run. So let's divide by 3, top and bottom here, and rewrite our question. 9 divided by 3 is 3. And 12 divided by 3 is 4. And this is divided by 6 over 7. Okay, now that we have something more simple to work with, let's look at the rules. When you are dividing with a fraction, what you do is you take the second fraction you flip it, and you multiply it. Now what the heck does this mean? Don't worry, I'll show you. 3 over 4, and now because we're going to flip this second fraction, it becomes 7 over 6. This is called a reciprocal, okay? And we're going to turn that into a multiplication sign. So now 3 times 7 is 21, and 4 times 6 is 24, and these can be simplified. We can divide by 3 on the top and the bottom. 21 divided by 3 is 7, and 24 divided by 3 is 8. So our answer to number 7 is 7 over 8. So just to recap, when we're multiplying with fractions, when we're dividing with fractions, we take the second fraction, we flip it, and we multiply them. Okay? So I want you to give that a try. Let's see. Do we have another one? Yes, we do. With number 8. So give number 8 a try. It looks like these are perfectly simplified, so you don't have to worry about simplifying them. Just flip that second fraction and multiply. I will give you a chance to work this out on your own, and then I'll go over it with you. Good luck. All right, I hope you got it. Here we go. I'm going to go over the question with you. So like I said, when we're dividing, I keep saying the wrong one. When we're dividing with fractions, we take the second one and we flip it. So we multiply by the reciprocal. So this becomes 3/8 times 2 over 1. 3 times 2 is 6. 8 times 1 is 8. We're going to divide by 2 on the top and the bottom because we want to simplify. These are both even numbers, so I know I can divide them by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And our answer for number 8 is 3 over 4. Okay, I hope that makes sense. We're going to move on to a new topic. We're going to move on to mixed numbers, which I promised you we would. So you may be asking yourself, what's a mixed number? You see here, a mixed number is a fraction that has a whole number with it. And that fraction is added to it. So if we have 2.5, this is a mixed number. Okay? Now a mixed number comes from what we call an improper fraction. So these two numbers are actually equal to each other. What's happening here is that they're in different formats. The mixed number is considered the most simplified form. So if you remember how we talked about simplifying fractions, this is what we need to know about mixed numbers, that having it as a mixed number is the most simplified form. And even as a mixed number, the fraction part, you need to make sure it's simplified. So here it's important to know, how do we convert between these two formats of a fraction, the mixed number and the improper fraction? It's called an improper fraction because the numerator is bigger than the denominator. Okay? So how do we switch between these two? Let me make a little room for us here. The way we switch them is, I'm going to go this way first. The first thing we do is we divide. To get from 5 over 2 to 2.5, we divide the numerator by the denominator. So the top number by the bottom number. So 2 goes into 5 2 times. 2 times 2 is 4. And I get a remainder of 1. So what we do here is this number right here becomes my whole number. The remainder becomes my new numerator. And my denominator stays the same. So I might have done that quickly. I'm going to show you another example. We're going to do 6 divided by 5. 5 goes into 6 one time. That becomes my whole number. 5 times 1 is 5. I subtract. And I get a remainder. That remainder becomes my numerator. And my denominator stays the same. So this is 1 and 1/5. Okay? So I'm going to give you one to try. I want you to try doing 8 over 3. There's a good time to pause and give it a go. But if you're ready, then I'm going to explain it to you. So we divide 8 by 3. 3 goes into 8 2 times. That becomes my whole number. 3 times 2 is 6. 8 minus 6 is 2. This becomes my remainder, which is my new numerator. And my denominator stays the same. So 8 over 3 is an improper fraction. And when it's converted to a mixed number, it's 2 2/3. Okay. Now that we have that, let's go ahead and take a look at converting a mixed number to an improper fraction. So we're going to go in the other direction. So our original example was 2.5. How do we go from 2.5 to an improper fraction? Well, we first multiply and then we add. So 2 times 2 is 4. 4 plus 1 is 5. That becomes my new numerator. And the denominator stays the same. Okay? So I multiply and I add, and that gives me my new numerator. The denominator stays the same. I'm going to show you another one. Let's do 3 2/5. 5 times 3 is 15. Plus 2 is 17. And my denominator my denominator stays the same, so it's 17 over 5. Okay? If you're ready, I'm going to give you one example to try on your own. All right, give that a go. It's a good time to press pause. If you're ready, let's go ahead and review it. 7 times 1 is 7, plus 2 is 9. And my denominator stays the same. Okay, awesome. I hope you got that. So this is the very first step with mixed numbers. I'm going to clean this up, and I'm going to make some space for us. So now that we know how to switch between mixed numbers and improper fractions, we are able to do the super fun stuff with actual mixed numbers. So what we're going to do now is see how to add and subtract these mixed numbers. So when we're adding and subtracting, remember the original rules for fractions is we're going to give them the same denominator. But before we can do that, what we need to do is convert this mixed number into an improper fraction. So step 1, convert. Okay? Here we're going to multiply, we're going to add. 5 times 2 is 10, plus 1 is 11 over 5. And I can bring down the next one. This other fraction is already a regular fraction, so we don't have to do anything special to it. Now that we've converted, step 2 is give the same denominator. How do we do that? Well, remember when we were going over this earlier, what we did is we multiplied the top and the bottom by the denominator of the other fraction. So this is 77 over 35 plus 6 times 5 is 30 over 35. So now that they have the same denominator, now we can move on to step 3, which is add or subtract whatever it is that you got to do. Okay? So 77 plus 30 is 107 over 35. Okay, so now that we've done that, we move on to step 4, which is to simplify. Remember, simplifying means dividing top and bottom by the same number, but it also means that we turn it back into a mixed number, and we do that by dividing. So 107 into 35. Well, 35 times 1 is 35, and 35 times 2 gives me 70. We can try 35 times 3. That's going to give me 1,505. That is as close as we can get. So we're going to put a 3 here. This becomes my whole number. I'm going to put 105 down here, and I'm going to subtract. 7 minus 5 is 2. This is my remainder. So that becomes my new numerator, and my denominator stays the same. So the answer here is 3 and 2 over 35. So these were kind of big numbers, so it might have been a little confusing, but I'm going to go ahead and show you another example with smaller numbers. I'm going to delete this real quick. I'm going to show you another example with smaller numbers so that this can make a little more sense for you, okay? So let's say we're doing 1.5 plus 1 1/3. Remember, step 1 is convert. So multiply, add, multiply, add. Here we do have to do both of them. 2 times 1 is 2, plus 1 is 3. Denominator stays the same, over 2. Plus 3 times 1 is 3, plus 1 is 4. This gives me 4 over 3. Now that I've done that, now I'm going to go to step 2, which is give them the same denominator. I'm going to multiply this side by 3 and this side by 2. That gives me 3 times 3 is 9. 3 times 2 is 6. Plus 4 times 2 is 8. 3 times 2 is 6. 9 plus 8, that's step number 3, we're going to add them. That gives me 17 over 6. And now I'm going to simplify, and I do that by turning this into a mixed number all over again. So here, 6 times 2 gives me 12, and 6 times 3 gives me 18. 18 is too big, so we're going to stick with 2. That becomes my whole number. 6 times 2 is 12, and 17 minus 12 is 5. That is my remainder, which becomes my new numerator, and my denominator stays the same. So my answer is 2 and 5 over 6. Okay, I hope that one with smaller numbers made a little bit more sense. You already know how to add and subtract fractions. All we're doing here is adding the extra steps of converting at the beginning and converting again at the end. Okay, that's all we're doing. So let's go ahead and take a look at another example. I'm going to get rid of all of this mess so we have some space to work with. And I want to give you number 2 so you can give it a try. This is a good time to hit pause and try this one on your own. When you're ready, we can go over it. So with this one, once again, we're converting, right? 3 times 6 is 18, plus 2 is 20 over 3. And then the 1/4 stays the same because it's a regular fraction. Step number 2 is we give them the same denominator. So we're going to multiply by 4 to this side and by 3 to this side. So 4 times 20 gives me 80. 4 times 3 gives me 12. 1 times 3 gives me 3. And 4 times 3 gives me 12. Now I can add them together. 80 plus 3 is 83 over 12. And there we are. We're going to go ahead and divide this to simplify because that's our last step. So 12 goes into 83. So 12 times 6 is 72. 12 times 7 is 84. So that's too much. We're going to do 6. 12 times 6 is 72. 6 becomes my whole number. I subtract. 3 minus 2 is 1. 8 minus 7 is 1. This is my numerator, or my remainder, which becomes my numerator. I put it up here with the numerator, and the denominator stays the same. So the answer here is 6 and 11 over 12. All right, there we are. I hope you got that. I hope this is making sense. If you're ready, we're going to go ahead and look at another example. So in this example, we are subtracting. Go ahead and hit pause here. Give this question a try. When you're ready, let's review it. So with this one, we are going to go ahead and convert. This is 9 times 8 is 72. 72 plus 2 gives me 74 over 8. Minus 4 times 7 is 28. 28 plus 3 gives me 31 over 4. Now, I want to convert this. I already converted it, but I want to give it the same denominator. If I multiply this side by 2, the 4 times 2 gives me 8. So I don't have to multiply them by each other. I can actually take this little shortcut here, okay? So the first one stays the same, minus the second one is 62 over 8, because I multiply these two. So now they have the same denominator. Now, 74 minus 62 gives me 2, 12 over 8. Here, I notice before I turn this into a mixed number, I can simplify top and bottom by 4, and I'm going to do it. 12 divided by 4 is 3. 8 divided by 4 is 2. It's still an improper fraction, so I still need to divide. But now I'm working with a smaller number, so it's a lot easier. 2 goes into 3 one time. 2 times 1 with a remainder of 1. And my denominator stays the same. So my answer here is 1.5. Now, if you did not realize that you could simplify before turning it into a mixed number, and you did it afterwards, that is completely okay. The important thing is that your final result is 1.5. Okay? This just goes to show us that we can simplify at any one of these points, and it would still work. All right, so here is your next example. Go ahead and hit pause here and give it a try. But if you're ready, I'm going to go ahead and review it. So once again, I'm converting. 5 times 7 is 35. 35 plus 3 is 38. Minus 40 plus 3 is 43 over 10. Once again, we have here one situation where if we multiply this side by 2, the denominator would be 10. So we can just multiply this one side and we don't have to do the other side. So 2 times 38 gives me 76. 2 times 5 is 10. Minus 43 over 10. If you have to pause at any point while I'm doing this because you want to work out any of the math, like the multiplying that I do in my head, you might need the time to do it out on paper. That's completely fine. Feel free to do so at any point, okay? So here, 76 minus 43. I'm going to show you the math for this one. 6 minus 3 is 3. 7 minus 4 is 3. So 33 over 10. Now, it does not look like I can simplify this one at this point, so I'm going to divide. 10 goes into 33 3 times. This becomes my whole number. 10 times 3 is 30. 33 minus 30 is a remainder of 3. That becomes my numerator, and my denominator stays the same. So this is 3 and 3 tenths. All right, these are our examples on adding and subtracting. I hope this is making sense to you. I hope it's helping. I want to go ahead and show you some examples where we're multiplying and dividing. We're essentially doing the same thing of converting at the beginning, doing the operation, and then converting at the end. So I expect for it to be pretty easy for you at this point. but I do want to review a couple of examples with you. Okay, so here's our first example with multiplying. Step number 1, like I said before, we are converting. 5 times 1 is 5, plus 3 is 8, so this is 8 over 5, times 10 times 2 is 20, plus 3 is 23, denominator stays the same. So I just want to remind you that when we're multiplying with fractions, we don't have to convert, we don't have to give them the same denominator. Once we've converted them, all we have to do is multiply straight across. So we got 8 times 23, which I don't know off the top of my head, so we're going to do the math real quick. That's 24, 16 plus 2, 184, over 5 times 10 is 50. So I want to work with smaller numbers. I'm going to start off by dividing by 2 top and bottom to simplify this. Okay, and the reason I'm doing that, like I said, is because I want to work with smaller numbers. So 2 goes into 18 9 times, brings down the 4, 2 goes into 4 2 times. So it's 92 over 25. Okay, now that I've simplified and my numbers are a little smaller, now I'm going to go ahead and divide. So 25 goes into 92 3 times. 25 times 3 is 75. So 3 is my whole number. So I'm going to subtract here. This becomes 8. 12 minus 5 is 7. 8 minus 7 is 1. My remainder is 17, which means my numerator is 17. So my answer here is 3 and 17 over 25. So once again, I converted, I went ahead and did the multiplying, and then I converted again. Super easy stuff, guys. You got this. All right, go ahead and give this one a try. When you're ready, give it a try. Go ahead and hit pause so you have time to do it. And when you're ready, come back, and I'm going to go ahead and explain it. So convert, 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 convert. Here we go. 54 plus 4 gives me 58 over 9 times 7 times 1 is 7 plus 2, 9 over 7. Okay, I do not know 58 times 9 off the top of my head, so I'm going to multiply. Gives me 72. 45 plus 7 gives me 52. So 522 over 9 times 7 is 63. Okay, so now what I'm going to do is, it looks like I can divide by 3. I'm going to divide by 9, both top and bottom. When I do that, I actually get 58 over 7, which is a much easier number to work with. Now, I did not do the math for you there. If you want to pause and do 522 divided by 9 and 63 divided by 9, you're welcome to do so to catch up, okay? Now that I've done this, I'm going to divide, okay, so that I can get my mixed number. 7 goes into 58. So let's see. 7 times 6 is 42. 7 times 7 is 49. 7 times 8 is 56. So it looks like 8 is the closest one, and that is my whole number. 58 minus 56 gives me 2. That is my remainder, so that becomes my new numerator. And my denominator stays the same. So 8 and 2 over 7. So I know these numbers are a little challenging, they're big numbers, but that is completely okay. That's why we're practicing with this. I want you to get the challenging stuff and be comfortable with this, so that when you get difficult questions on the ASVAB, you're not scared of them. You know exactly what to do. All right, so finally, I want to go ahead and show you how to divide with mixed numbers. So same thing all over again. I'm just going to show you one example of this. 8 times 2 is 16. 16 plus 7 is 23 over 8. Divided by 48. 48 plus 5 gives me 53 over 8. Now, remember that when we're working with division, when we're dividing fractions, what we want to do is we want to take the second fraction and we want to flip it. So 23 over 8 times 8 over 53. And now we can multiply straight across. 23 times 8, 24, carry the 2. 16 plus 2 is 18. And 8 times 53, 24, carry the 2, 40 plus 2, so 424. So these are actually even numbers. We're going to divide by 4 top and bottom, or actually we can divide by 8 top and bottom. And we know that because we see that there's an 8 in the top and the bottom here, which gives us just 23 over 53. I know that seems like we worked against ourselves, but that's okay. Now here we have a fraction that the numerator is smaller than the denominator. That means that this is a regular fraction. We do not have to simplify this. We do not have to turn it into a mixed number. And this is our actual final answer here. So with dividing, it can be a little bit different because the result is not necessarily going to be a mixed number. So you might have to convert at the end, but you might not have to convert. You might have to convert in the beginning, but you might not have to convert in the end. Okay? All right, that is basically it for fractions video today. I know I went over a lot in this lesson, so please do not get overwhelmed. Take your time. Remember, this is a video. You can come back, watch it, pause, review things again and again. But as always, there's a quiz for you below, so go ahead and do it. And there's also an explanation video below to help you with any questions you might not understand. All right, good luck, and keep doing a great job as you study for the ASVAB. So now we're Operations with decimals have different rules, and the rules change depending on whether you're doing adding, subtracting, or multiplication, division. So the rules are the same for adding and subtracting, which means what you need to do is line up the decimal. So here, this 6 dot is just the number of the question, the question number. So ignore that. But we're focusing on 2.9 plus 10.3. So what is that going to look like? Well, 2.9 and 10.3. Okay, that's what that's going to look like. Our decimals are lined up. If you can see that here, this is one decimal, this is another decimal here. Okay, and if you notice, my 10th place is lined up, my 1's place is lined up, and my 10's place is lined up. Okay, so now we add this, and we get 9 plus 3 is 12. So I'm going to put a 2, and I'm going to carry over the 1. Because there's a decimal here, I'm going to put a decimal in my answer. 1 plus 2 is 3, plus 0 is still 3. So I'm going to put a 3, and nothing to carry, so we just have 0 plus 1 is 13.2. Okay, so the answer to this is 13.2. So important to remember, line up those decimal points. I'm going to highlight it for you here. Line up those decimal points. These decimal points have to be together, and we keep them together here in your answer. Okay, so let's take a look at another question. I'm not going to bombard you with number 7. Let's look at number 8. Let's look at number 7 before you give one a try on your own. So here we have 5.72 plus 10.88. You see how we have the decimals lined up here? Now we can add stuff up. So 2 plus 8 is 10. 0, carry the 1. 1 plus 7 is 8. Plus 8 is 16. So we're going to do 6, carry the 1. 1 plus 5 is 6. Please notice that I did bring down my decimal here. So I had my decimals and they're lined up. I'm going to highlight it real quick so you can see it. So these decimals are lined up here, okay? Where was I? Okay, so 1 plus 5 is 6. We didn't carry anything over, so we just have a 1 here. 0 plus 1 is 1. So the answer to this one is 16.60. But when there's a 0 and there's nothing behind it after a decimal, it also could be written as 16.6. They both mean the same thing. I just want to make sure to say that to you in case that's something that's confused you before, okay? All right, so give number 8 a try. I'm going to pause for a second, or you can pause the video. Give number 8 a try, and I'll go over it with you just to make sure you understood. Now notice here for number 8, this is a subtraction problem. The rules are the same. You are still going to line up the decimals here, okay? Sorry about that. You are going to line up the decimals. Remember, the 8 is just the number of the question. But you are lining up these decimals, and go ahead and subtract them, okay? Good luck. Okay, perfect. I hope you got it. If not, don't worry. I'm going to go over it with you now. 6.6 minus 4.99. So this one might have been a little more challenging because we have this random space here with no number, okay? So you have to make sure that the 1's place is lined up and the 10's place is lined up. But here, we don't have anything to be above this 9. So what we do is we fill it in with a 0, okay? Now remember over here, I'm going to bring you back to this real quick. Remember over here, we had 16.60 as our answer, but I told you that if there's a 0 behind the decimal, it doesn't affect you to write it 16.6. In the same way, if you have a 16.6, you can rewrite it as 16.60. So here we have 6.6. We can write it as 6.60. It's fine. It's not a bad thing. We can totally do that. Okay? So now that we've discussed that, we understand that, let's subtract. Well, we can't do 0 minus 9 because 0 is too small. So that means we need to borrow from the neighbor. Okay? When we borrow, this becomes a 5. We subtract 1 from here, becomes a 5. And this gets 10 added to it. 0 plus 10 is 10. So now, 10 minus 9, we can do it, is 1. 5 minus 9, can we do it? No, because 9 is bigger than 5. So we have to borrow from 6. This becomes a 5. Remember, we add 10 here, so it becomes a 15. 15 minus 9 is 6. We just came across the decimals, so we're going to bring it down. And now 5 minus 4, we can do it because 4 is smaller than 5, and 5 minus 4 is 1. So our answer for number 8 is 1.61. Okay? I hope you got it. If not, don't panic. Give number 9 a try, and hopefully you'll get this one without my help. And if you can't, don't worry, I'll go over this one as well. Okay, so how'd it go? Hopefully you got it. If not, don't worry. Remember, the first thing we want to do is we want to line up our decimals. So 2.313 and 1.9944. And look at that. We got to fill in a 0, okay? So we can't do 0 minus 4 because the 4 is too big, which means we're going to borrow from our neighbor. And we're going to add 10 to this, so this becomes 10. 10 minus 4 is 6. 2 minus 4, we can't do it because the 4 is too big. So once again, we're going to borrow. This becomes 0. This becomes 12. 12 minus 4 is 8. Here, we can't do 0 minus 9. So once again, we have to borrow from our neighbor. This becomes a 2. We add 10 to the next one. So this becomes a 10. I'm sorry, that's a little difficult to see. Okay, that's a little better. 10 minus 9 is 1. So we've already used this one, we've already used this one, we've already used this one. I'm crossing them out so it's easy to see. Now we're 2 minus 9. That's the one we're working on next. We can't do 2 minus 9 because 9, once again, is too big. So we're going to borrow from the neighbor. This makes this one 12. So 12 minus 9 is 3. We used it. We're going to include our decimal because it's lined up here. And 1 minus 1 is 0. So the answer to this one is 0.3186. Okay? So I hope that made sense. Give number 10 a try before we move on to multiplication. let's give it a try together just to make sure. Let me see here. Okay, so 16.301 minus, remember our decimals go lined up, so I'm going to put the decimal here, 4.0842. We fill in with a 0, we get started. So here we can't do 0 minus 2, we're going to borrow. This becomes 0, this becomes a 10. 10 minus 2 is 8. Now here we can't do 0 minus 4, so we have to borrow from our neighbor. Now this one's kind of weird, because we're looking at the neighbor, and the neighbor doesn't have anything we can borrow from. So before we can borrow from this neighbor, the neighbor has to borrow from their neighbor. So this becomes a 2. Oops, sorry. Let's zoom it in. This becomes a 2. This one borrows and becomes a 10. So remember we were over here. We were on this one, okay? And we need to borrow from its neighbor because we can't do 0 minus 4. So now this one becomes a 9, and this one becomes a 10. Okay? 10 minus 4 is 6. 9 minus 8 is 1. 2 minus 0 is 2. Decimals are lined up, so we line it up down here. 6 minus 4 is 2. And 1 minus 0 is 1. So the answer to this one is 12.2168. That was a tricky one, so if you got it, congratulations. I'm really proud of you. If you didn't, don't worry. If you have to rewind real quick in the video, feel free to before we move on to multiplication. If you're ready, let's go ahead and take a look at some multiplication problems. Alright, so the rules with multiplication are a little bit different. When we multiply, we are essentially going to ignore the decimal points until we are finished multiplying. We only apply the decimal points to our actual product. And remember, product is the word we use for what we get when we multiply numbers together. So we're just going to write our number 6.8 times 4.7. I know here the decimals are lined up, but it's just because it happened that way. I didn't actually line up these decimal points. But we're going to do 6.8 times 4.7. So we're going to, remember, multiply, ignore the decimals, pretend they're not even there until the very end. So we're going to do 7 times 8, which is 56. We put a 6 here, and we carry a 5. Then we do 7 times 6, which is 42. We're going to add that 5 that we carried over, which makes it 47. And we're going to fill in with a 0. And now we're going to start with our 4, multiplying with our 4. So 4 times 8 is 32. I'm going to carry a 3. I'm going to cross out the 5 so I don't confuse myself or you. And now we have 4 times 6 is 24. Plus 3 is 27. So now that we've done that, we're going to add everything. Notice I haven't used my decimal points yet. Okay, I'm kind of ignoring them for now. But there will be a moment where we will use them, so don't worry. So now 6 plus 0 is 6. 7 plus 2 is 9. 4 plus 7 is 11. So I'm going to put a 1, carry a 1. 1 plus 2 is 3. So 3196. Now that we've done that, we're going to go back and take a look at the decimals. Okay, in my multiplication problem, I have one number behind the decimal point and two numbers behind the decimal point. So 1 and 2, which means in my answer, I will have two numbers behind the decimal point. So 1, sorry, that's going to be a little confusing. 1, 2. So my decimal point goes there. So the answer to this is 31.96. Because if my question has two numbers, 1, 2, okay, behind the decimal point, then my answer will also have 2 behind that decimal point. Okay? I hope that makes sense. Let's go ahead and do 12 together before I unleash you into the world of multiplication. Actually, go ahead and do number 12 on your own because I will go into the world of division soon. So do 12 on your own. Give it a try. I'll give you a second, and then I'll go over it with you briefly. Okay? All right. I hope that worked. It went well. I'll go over it with you real quick, just to make sure you got it. So 13.45 times 2.6. So here, please notice my decimal points are not lined up. I'm just going to multiply, okay? We're just multiplying here. So 6 times 5, we're going to start there, is 30. So I put 0, carry the 3. 6 times 4 is 24. Plus 3 is 27. So I'm going to put a 7, carry the 2. 6 times 3 is 18, plus 2 is 20. So I'm going to put a 0, carry the 2. 6 times 1 is 6, plus 2 is 8. So I'm done with these. Let me cross them out so I don't confuse myself. I'm going to put that placement 0 here. And now I'm ready to multiply with my 2. So 2 times 5 is 10. 0, carry the 1. 2 times 4 is 8, plus 1 is 9. Nothing to carry. 2 times 3 is 6. Again, nothing to carry. And 2 times 1 is 2. So 0 plus 0 is 0. 7 plus 0 is 7. 0 plus 9 is 9. 8 plus 6 is 14. Put a 4, carry 1. 1 plus 2 is 3. So now that I've done that, I'm going to go 1, 2, 3 numbers behind the decimal point. Remember, we're looking to see how many numbers are behind the decimal point. However many there are, 1, 2, 3, that's how many there are going to be in my answer. 1, 2, 3. So my decimal point goes there. So my answer is 34.970. And that's it. Awesome. I hope you got it. If you didn't, feel free once again to rewind and kind of see where you went wrong. And I'm going to go ahead and move on to division. Okay? I want to explain. So division has two different scenarios. Okay? So sometimes in division we'll have, and I'm going to write it out for you so you can kind of see it. Sometimes in division we'll have the decimal here. Okay? In the number that's being divided. Or other times we'll have the decimal out here. You see the difference? Sometimes we'll have the decimal in both places. Okay, so I'm going to go over all those scenarios. I'm going to start with the easiest one, which is this one. This is why this is the first question we're taking a look at, and then I'll show you how to do the other ones, okay? So let's take a look. Let's get started with this one. When we have a decimal in the inside, we just kind of line up the decimal. It doesn't really affect us too much. So I'm going to write this out so you can see it. 37, oops, sorry about that. Let me zoom in again for you. 3782.4. All right, so 22 goes into 37 one time, okay? Oh, 1. Okay, sorry about that. I don't know what happened. 37 minus 22. So just to make sure we understand, this number right here goes inside. This number right here goes on the outside. When we divide, we ask ourselves, how many times can this number on the outside go into this number here on the inside? And we go one by one. So like technically we would have started as 22 goes into 3 0 times because 22 is way too big. But because it's way too big and I didn't want to write a 0 up here for you, I moved over and immediately started with 22 into 37, which I know 37 is big enough and 22 can go in once. So I put the 1 up here. I put how many times the 22 can go into 37 up here, and then I multiply them, 22 times 1, and I put the product down here, 22. Okay? Now I subtract them to see what's left over. So 7 minus 2 is 5, and 3 minus 2 is 1. Okay, oops, I lost the 8 there. All right, there we go. Now that we've done this, to make sure we did this correctly, we ask ourselves, is this remainder smaller than this? It is. It is smaller, so we can keep going. Now we bring down our 8. We bring down the next number to work with. So 22 goes into 158. Well, definitely more than once, okay? So one way I kind of like to do this when you're working with larger numbers is I try to round each number. So 22 is pretty close to 20, okay? And 158 is pretty close to 160, okay? So 20 to 160, I can multiply 20 times 8 to get 160. Okay, that could work. But I will say this. That might be a little too big. So to make sure I don't waste my time there, I'm going to do 22 times 7. Now, the reason we do this estimation process is to avoid writing like 4 or 5 different multiplication problems, trying to guess around to see which one works. You just want to go straight to it. And estimating helps you find it as quickly as possible, okay? So here we go. 7 times 2 is 14. So we put a 4, we carry a 1. We're going to ignore this 20. That's not part of this. Just in case, I don't want to confuse you. 7 times 2, once again, is 14. Plus 1 is 15. Okay, so 22 times 7 is 154, and that's perfect. So I'm going to put a 7 up here, because that's how many times 22 goes into 158. And I know that 22 times 7 is 154, so I'm going to put that down here. And now I'm going to subtract them to see what's left over. So 8 minus 4 is 4, 5 minus 5 is 0, 1 minus 1 is 0. I don't have to do anything with that. 4 is definitely smaller than 22. Let me clean this up for you real quick. And I'm good to go. So now I bring down, Now I bring down the 2. Okay, 22 goes into 42 one time. So I know, and I'm going to show you why. 22 times 2, 2 times 2 is 4, 2 times 2 is 4. It's 44. So I can't go up to 2. I have to stay at 1. Okay? So I'm going to put 1. 22 times 1 is 22. 2 minus 2 is 0. 4 minus 2 is 2. And there we go. Now we finally got, I know it took us a while, but we finally got to our decimal. Now, when we get to our decimal, we have to make sure that our decimal is lined up at the top where the answer, where we're writing our answers, and where it is inside that division sign. Okay? So now that we did that, now we can bring down the 4 and we can keep going. Okay? So now, 22 goes into 204. Guess what we're going to do? We're going to estimate. Okay? So I know that 20, remember it's close to 22, can go into 200 about 10 times, okay? But I'm going to bring it down 1, so I'm going to do 9, just to make sure that we get it, because I think it'll be too big. So 22 times 9, 9 times 2 is 8, it's 18, but I'm going to put an 8 in here, the 1. 9 times 2 is again 18, plus 1 is 19, so we're going to do 198. Now, we can't do 4 minus 8, we have to do 14 minus 8, so we're going to have to borrow from the neighbor who's borrowing from the neighbor. This becomes 10, so we can borrow from it, it becomes a 9, and this becomes a 14. So 14 minus 8 is 6, 9 minus 9 is 0, 1 minus 1 is 0. Okay? Oh, I'm so sorry. I completely forgot to put 9 up here for you. I'm so sorry about that. That could have been a big mistake. We could have gotten the question wrong. So I'm glad I realized it. But 22 times 9 is 188, so I put that up here. I bring down that 198 here because that's my product. And when I subtract, I get a remainder of 6. So now we can keep going, but this is going to give us a long decimal. And what I really just wanted to show you was what to do when you have a decimal in your division problem. So I don't want you to worry about getting rid of our remainders now. We're just going to kind of leave it here. Okay, we're going to leave it a little incomplete. Now, let's go ahead and, let's do another one like this. And I'm just going to write it for you by hand so we can get a little bit of practice, okay? Because the next one moves to a different kind of division with decimals. And I want to make sure you get this before we move on to that. So our next problem is going to be 3 into 26.4. Okay? So working with small numbers, we're just practicing using that decimal point, okay? So 3 goes into 2, it's too small. So we're going to move on to the next one. 3 goes into 26. Well, we know that 3 times 8 is 24, so we're going to put an 8 up here. 3 times 8 is 24. 26 minus 24. 6 minus 4 is 2. 2 minus 2 is 0. Now we get to our decimal point, which means we're going to put it up here, okay, behind the 8. Now that we've done that, we're going to bring down our 4. 3 goes into 24 once again, 8 times, okay? 3 times 8 is 24. 24 minus 24 is 0. Got it? So let's do another one like that. I'm going to let you try this one on your own, and I'm going to give you a second to work it out. We're going to do 3 into 409. Let me extend it a little bit. 0.2. Yes, 409.2. Okay? Give that one a try. I'll give you a second, and then we'll go over it together just to make sure you got it, okay? Okay, perfect. So now, let's do this one at a time. 3 goes into 4, one time. 3 times 1 is 3. 4 minus 3 is 1, which is smaller than 3, so we're good. We're going to bring down that 0. 3 goes into 10. 3 times, because 3 times 3 is 9. So 3 times 3 is 9, 10 minus 9 is 1. Let's bring down that 9. This becomes 19. 3 goes into 19 6 times, right? Because 3 times 6 is 18. So 19 minus 18 is 1. Now we got to our decimal. So we have to put our decimal before we move forward. Now we can bring down our 2. And this becomes 12. 3 goes into 12 4 times. 3 times 4 is 12. 12 minus 12 is 0. So our answer is 136.4. Okay, so now that we've gone over a couple of these, I hope you get it. I hope you see how we got to pause and line up that decimal. Now we're going to add another layer to this. We're going to look at questions that have the decimal on the outside, okay? You see how it has it here? Write the question, it'll make a little more sense. So let's write the question out. 1.4 into 624. Okay? Whenever we have a decimal here on the outside, we need to get rid of it. We can't keep it there, okay? So what we do is we're going to move it to the right one time to get rid of it. It's almost like to hide it away. Now let me explain something. All numbers have a secret hidden decimal in them. All whole numbers do, okay? Even if you can't see it. So 5 is the same thing as 5.0, okay? Here, 624 is the same as 624.0, okay? So now with that said, we're going to bring this over 1. We know that there's a decimal point at the end of this, okay? 0.0. So if we do this, whatever we do to the outside, we're going to do to the inside as well, okay? Which means this can be rewritten as, now it's 14, because we got rid of that decimal point. It's here at the end now. And that it goes into 6240, because we move that decimal point to be behind the 0, okay? I hope that makes sense. Now let's go ahead and divide. 14 goes into 62. I want to say, let's try it out. I know 14 times 5 is 70. So let's try 14 times 4. 4 times 4 is 16, so we're going to carry 1. 4 times 1 is 4, plus 1 is 5, so 56. We can't add 14 to this, because if we do, we get to 70. So we're going to use 4 here, okay? So 14 times 4 is 56. 12 minus 6, sorry. I can't do 2 minus 6, because 6 is too big, so I have to borrow. This becomes 5, this becomes 12. 12 minus 6 is 6, and 5 minus 5 is 0. So I'm going to break down my 4. Now, 14 goes into 64. I know it's going to go 4 times, because I know 14 times 5 is 70. And I'll work it out here for you. 5 times 4 is 20, so I'm going to put it 0 and carry the 2. 5 times 1 is 5, plus 2 is 7. So it's 70, okay? So that's too much. So we're going to keep a 4. We're going to keep it at 4. So 14 times 4 is 56. We're going to subtract 56 from this. This becomes a 5, because we can't subtract 6 from 4. It's way too big. And this becomes a 14. 14 minus 6 is 8. Now we're going to bring down our 0. 14 goes into 80 5 times. Oh, we know that happens to be 70. 14 times 5 happens to be 70. And now we're going to subtract, and we're left with a remainder of 10. Okay? I'm not going to go over decimals right now with division. I'm just showing you how to divide with decimals in here. Okay? All right, let's take a look at another problem. Once again, I'm going to give you a problem. I'm going to write it for you. And this one is going to have the decimal on the outside and the inside. So let's say we have 1.2 goes into 3.684. Okay? Now, remember, we can't have this on the outside. This doesn't work. So I have to move it 1 to the back to get rid of it. So it kind of disappears, becomes invisible. And whatever I do to the inside, I'm also going to do to the outside. I'm sorry, I got that backwards. Whatever I do to the outside, I'm going to do to the inside. So this gets rewritten as 12 goes into 36.84. Okay? So now 12 can't go into 3 because it's way too small. So we're going to do 12 into 36. So 12 times 3 is 36. 36 minus 36 is 0. We got a decimal here, which means we have to line it up. Now I can bring down my 8. 12 goes into 8 0 times because it's way too small. But now we have to write that there because it's in the middle of our problem, like our answer. So we do have to write that 0, okay? So now that we've done that, 12 times 0 is 0. 8 minus 0 is 8. Let's do that. We're bringing down our 4. 12 times 7 is 84. We bring that down here. 84 minus 84 is 0. So our answer is 3.07. All right. Now that we got that, let's move on to another question. Give this one a try on your own before I help you out with it. Okay, I hope you got it. If not, don't worry, I'm going to go over it with you right now. So, let's write this. Oh, no wonder. Okay, 2.9 goes into 227. Well, guess what? I can't have this decimal here. I'm going to move it to the back, which means I have to move this to the back. Okay, so this gets rewritten as 29 goes into 227. So 2,270. So 29 cannot go into 22, but it can go into 227. Now 29 is very close to 30. And 227 is very close to 230. So if we count by 30s, if we multiply, we could do 30 times 7, which gives me about 210. That's pretty close. So let's try 29 times 7. So it's probably going to be like 29 times 7 or 29 times 8 or something like that. Okay, so let's give it a try. 7 times 9 is 63. I'm going to put a 3, carry the 6. 7 times 2 is 14, plus 6 is 20. So we got 203. Let's try 29 times 8 and see how that works. 8 times 9 is 72. So we got a 2, we're going to carry the 7. 8 times 2 is 16, plus 7 is 23. 232. So even though 8 is pretty close, giving us 232, it goes over, so we can't use it. We have to do 29 times 7. So we're going to put a 7 up here. 29 times 7 is 203. We're going to subtract these lovely numbers. 7 minus 3 is 4. And 2 minus 0 is 2. Okay, now we're going to bring down our 0. 29 goes into 240. We know it's going to be about 8 times, right? Because of what we did over here. So let's put an 8. We have to borrow, because that is way too small. 10 minus 2 is 8. 3 minus 3 is 0. 2 minus 2 is 0. So we have 78 remainder 8 as our answer here. Okay? Well, I hope that made sense. Positive and negative numbers. So positive and negative numbers can be confusing sometimes for people, and I just want to go over it with you briefly to make sure you understand how to do it before we start hitting those heavy questions, okay? So the best way to look at positive and negative numbers is to see whether or not they have the same sign. Now, a number carries a sign in front of it, so I'm going to zoom in here so you can really pay attention to one problem at a time. Here, this 5 is carrying a negative in front of it, and here, this 6 is carrying a positive in front of it. So we can look negative 5, positive 6. And the way we do this is, with negatives and positives and adding them and all that, is if the signs are the same, we subtract. Okay? And the answer will have the same sign as the biggest number. Now, what in the world does that mean? Well, don't worry, I'm going to go over it with you right now. We're going to do number 1 together, and then I want you to give number 2 a try. Okay? So here, we're going to subtract them because there's a negative and a positive. Well, what's 6 minus 5? Well, 6 minus 5 is 1. Right? Now, it says that the answer will have the same sign as the biggest number, which is the biggest number, is 6. So the 6 has a positive, which means our answer will have a positive. Now, we don't have to actually write positive one. You don't usually do that. But we're just going to, I just put it there so you can see it. But your answer is just going to be 1. So now that I did that for you, give number 2 a try and see how you feel about it. I'm going to give you a second, and then I'll go over it with you. Okay, I hope you got it. If not, don't worry. Here, let's look at the sign that has in front of it, negative 8 and positive 17. They're different signs. So, I wrote here same. This should be different. The signs are different. Let's fix that there, I apologize. So if the signs are different, we subtract, the answer has the same sign as the biggest number. So here we have a negative and we have a positive, which means this rule applies. So we're going to subtract them. Well, what's 17 minus 8? 17 minus 8 is 9. We have a negative and positive. Now, the answer will have the same sign as the biggest number. The biggest number is 17, which means our answer will be positive as well. Okay? Now, what if the signs are the same? So, this was wrong. We're talking about different signs here. But if the signs are the same, then we add them. And keep the same sign. Let's take a look. Let's move on. Here we have 12 minus 18. If there is no sign, that means it's positive. This one has a negative 18. The signs are different, which means we subtract. So 18 minus 12 is actually 6. And which is the biggest number? The 18, which has a negative, which means our answer will also be negative. All right, give number 4 a try. I'll give you a couple seconds. You need to hit pause and go ahead and do so. And then I'll show you how to do it. Okay, so with number 4, we have positive and negative. The signs are different, which means we're going to subtract them. 14 minus 3 is 11. 14 is the bigger number, and it has a negative in front of it, which means our answer will be negative as well. Now with number 5, we see here negative 6, negative 8, or negative 6 minus 8. What's that rule? If the signs are the same, we add them. So 6 plus 8 is 14, and we keep the same sign, so it's negative 14. Okay? Give number 6 and 7 a try. I'll give you a couple seconds to do it, and then I'll go over them with you. So this is a negative 4 and a negative 13. They are the same sign, which means I add them. So I get 17, and the sign is negative, and I keep the sign. So this is a negative 17. Here we have a negative 2 and a negative 9. I add them because they have the same sign. 2 plus 9 is 11. The sign is negative, so I'm going to keep that sign, and the answer is negative 11. Now these look a little funky. Let me tell you how to do these. when we do these, we start applying the rules of multiplying and dividing positive and negative numbers, okay? Because we are imagining that there is an invisible one outside of this parentheses. So whenever we have a parentheses with like a positive, an outside or negative, an inside or outside or whatever it is, if we're trying to add and subtract positive and negative numbers, and we have this here, we're going to pretend like there's a 1 in front of that parentheses, between the parentheses and whatever sign is in front of that parentheses. And we're going to multiply, okay? When we multiply, the rules are a little bit different. Positive times negative is negative. Negative times positive is also negative. So the signs are different. The answer is negative. Positive times positive gives you positive, and negative times negative gives you positive. If the signs are different, we have negative. If the signs are the same, our answer will be positive, okay? So here, positive 1 times negative 4. Positive times negative is negative, so this gives me negative 4. The negative 4 wins. The negative wins, I mean. Now we can go ahead and treat this like a regular problem and say, okay, negative 12 minus 4, these have the same sign, so I'm going to add them, and I'm going to keep the sign, and that gives me negative 16. Here, same thing. We're going to put that 1 in between the sign and the parentheses. We have negative 1 times negative 8. Negative times negative is positive. So this becomes 13 plus 8. And 13 plus 8 is 21. Okay? Well, that's basically it. We're done with our positive and negative numbers. Remember the rules for multiplying. Remember the rules for adding and subtracting. If you do have any questions, you are always welcome to email me. I'll give you my email one more time at natalia@ltstutoring.com. Okay, well, good luck with your study. Hey there, this is Natalia from Nonstop Success. Thank you so much for joining me. In this class, what I want to review with you is how to do absolute value. So if you're ready, let's go ahead and get started. So you might be wondering, what in the world is absolute value? What does it look like? Absolute value looks like this. So here we have two straight lines surrounding the 5. So it's almost like a parentheses. Remember, parentheses are curved, okay? But absolute value has two straight lines. Those straight lines mean that everything inside of those lines is going to become a positive. So that sounds kind of funky, but I'm going to show you an explanation here. So here we have a positive 5 inside of there. So 5 absolute value is simply 5. Okay, super easy. Now let's look at another example. Here we have negative 5. Everything inside the absolute value always becomes a positive. So negative 5 in absolute value is equal to positive 5. All right, now let's take this a little bit further. Now, I know I said everything becomes positive, but what we want to do is simplify, and then after we simplify, we make it positive. That's what that means. So I'm showing you this example so you can understand what that looks like. Here we have 6 minus 4. We keep it in our absolute value sign. 6 minus 4 is positive 2. We keep the absolute value, and then we apply the absolute value afterwards. Well, positive 2 absolute value stays as just positive 2 because it's positive, okay? Now, another example here. Negative 3 plus 7. We process what's inside the absolute value sign. We leave it, sorry, that's not a very straight line, but we leave it here inside our absolute value. Negative 3 plus 7 gives me positive 4 absolute value, which is just positive 4. But let's say we have something that adds up or subtracts to give us a negative number. So a great example of this would be negative 5 minus 2. If we have negative 5 minus 2, what we do is we subtract, like we process whatever is inside the absolute value, and we apply the absolute at the end, okay? So negative 5 minus 2 gives me negative 7. I keep my absolute value lines, and this becomes positive 7. Another great example of this is negative 8 plus 7. Negative 8 plus 7 gives me negative 1, okay? When we apply absolute value, it gives me positive 1. Now, super important here. We cannot make everything inside positive and then add it all up. If we would have done that, we would have gotten 8 plus 7, and that gives us 15. That is incorrect. So the steps here are add, subtract, multiply, do whatever you need to do inside the absolute value. Once you find the single number, then you can go ahead and apply the absolute value, okay? So now that we have down how to do that, I want to make this a little more complicated. I want to help you level up. So now that we're going to level up, let's look at this next question. This says 8 plus 5 minus 12. Now we have things outside of the absolute value mixing in with inside the absolute value. So let's process it. Remember what I told you. We do the absolute value first. We do whatever's inside, then we apply it, and then we can interact with everything else. So this becomes 8 plus the 5 minus 12, we keep inside the absolute value. 5 minus 12 gives us negative 7, okay? Once we apply the absolute, this becomes 8 plus positive 7. So we write a positive 7 there. And now 8 plus 7 gives me 15, okay? So remember, the steps are process what's inside the absolute value first. 5 minus 12, negative 7. Then if now it's by itself inside the absolute value, now we can apply the absolute, it becomes positive 7, and then it interacts with the 8 that was already there. 8 plus 7 gives me 15, okay? So if you need to pause, take a look at this again, feel free to do so. If you're ready, let's go on to another example. Let me make some space here for us. Here is our other example, okay? If you want to give this a try, go ahead and pause the video now. If you're ready, let's go ahead and do this one together. So negative 8 minus 4. Remember, we do the absolute value first. Think of PEMDAS. If you've learned PEMDAS, what we have to do is the parentheses first. The first letter is parentheses, okay? So, parentheses first. Negative 8 plus 4 gives me negative 4. I bring down the 5 times 2 minus. Okay? Now, we apply the absolute to the negative 4. We leave everything else the same, and this becomes positive 4. I know it looks like it's a negative, but this negative comes from here, not from our absolute value. Okay? So, what do we do now? Now, we follow our PEMDAS. If you guys remember that. We did parentheses, there's no exponent. Next thing we do is multiply, okay? 5 times 2 is the next thing. So 10, and we bring down our minus 4. Then it would be divide, add, or subtract. Well, there's no division, addition, but there is subtraction. So 10 minus 4 gives us positive 6. So in case you're not familiar with PEMDAS, I want to give you a quick explanation. PEMDAS is, please excuse my dear Aunt Sally, or whatever it is that you learn to remember this, but basically it shows us what order to do things in. So P is parentheses, E is exponents, M is multiplication, D is divide, A is add, and S, squeezing it in here, is subtract. Okay, this is the order that we do stuff in when we have these long operations like this. Meaning there's like this long line of a bunch of numbers we need to add and subtract. It just tells us what order to do it in. Believe it or not, the order matters. So it's a good thing to learn this. Okay, all right. So now that we have this down, let's take a look at another example. All right, this example is a little similar. Here, what we're doing is we're multiplying to the absolute value sign, like the parentheses. So remember, the steps are do what's inside the absolute value first, and then use PEMDAS to figure out what to do with the rest of it. So go ahead and take some time now. You can pause the video and give this question a try. But if you're ready, let's go ahead and review it together. So remember, we start with the absolute value sign. What's inside of it? 1 minus 5. So I'm going to bring down everything else. Negative 8 plus 4 times, so that's not, like I know it's exponent, it needs multiplied, right? 1 minus 5 is negative 4, but inside the absolute value, it becomes positive 4. So I'm going to rewrite this here, positive 4. Okay? So remember PEMDAS. The next thing I have to do is multiply, because I don't have any exponents. So 4 times 4 is 16. So negative 8 plus 16. And now the only thing left to do is add. Negative 8 plus 16 gives me positive 8. And there we are. Okay, so this is just a quick explanation. Absolute value is pretty easy. It's just adding an extra step to things you already know how to do. Go ahead and do the quiz below to get that extra practice. And if you have any questions, always remember you can leave us a comment below. All right, good luck. Keep studying for that ASVAB. Hi, this is Nadalia from ASVAB Success, and in this video, I want to review with you the questions in the absolute value quiz. So if you struggle through this section, here is just a quick video to show you how to do each of the questions in the quiz, okay? Let's start with number 1. Remember that everything inside of our absolute value sign, we just do it normally, but the final answer within it is positive. So I'm going to rewrite it, just so it's a little easier. When we do 3 minus 9, we get negative 6, but we keep the absolute value signs. And remember, the absolute value will turn this positive. So here, our answer is positive 6. Okay, this one was pretty easy. I hope this makes sense. Let's move on to the next one. With this one, I'm going to rewrite it. There's a negative on the outside. So first things first, we do what's in the inside. 4 minus 6 gives me negative 2. I bring down my absolute value, and I bring down that negative. The absolute value makes my negative 2 positive. And this negative outside of it makes it negative again. So my final answer here is negative 2. So this one was a little confusing because even though we turned it positive with the absolute value sign, this negative sign out here turns it negative again. All right, I hope you got that. Let's keep going. So here, negative 9 plus 7 gives me negative 9 plus 7, negative 2. Absolute value makes it positive, so this becomes positive 2. And there you go. Okay, hopefully you're getting a rhythm with this. Let's keep going. Here, we have 7 minus 18 inside the absolute value sign. 7 minus 18 gives me negative 11. Keep the absolute value, that makes it positive 11. And look at that, I accidentally highlighted it for you. But yes, it's positive 11 here, okay? All right, let's keep going. Oops. Okay, number 5. Negative absolute value 5 plus 9. So here, the negative is in the outside. So we do whatever's in the inside. 5 plus 9 is positive 14. Okay, it stays as a positive 14, but we keep the negative in the outside. And that new negative gives me negative 14. And there we go. So remember, even though this is like, I think it was number 2, where the absolute value gets, like it works, but then there's a negative outside of it, so we apply it, and it turns our positive into a negative again. Okay? Okay, here we go, number 6. Here, 8 plus 17 gives me positive 25, and with absolute value, it stays positive 25. So that one is pretty easy. Let's keep going. Number 7. So here they start getting more complicated, right? So let's kind of break things down. Okay, first step is doing what's inside the absolute value sign. So negative 3 minus 1 gives me negative 4. I keep my absolute values, and I keep my 7 plus out here. Now, I keep focusing on what's inside the absolute value sign, right? The negative 4 with the absolute value becomes a positive 4. Now we can remove the absolute values because we finally applied them, okay? And we can bring down our 7 plus. So here, 7 plus 4 is going to give me positive 11. So my answer here is D. All right, so if you need to wash that again, okay? Remember, we always start with what's inside the absolute value. We keep simplifying or breaking it down until the absolute value sign is gone, and then we can mix it with everything in the outside. All right, I hope you got it. We got another one similar to it below, so let's try this again. Negative 5, absolute value 3 minus 7. So here, because there's nothing between the negative 5 and the absolute value, we always assume that this is multiplied. If there's a plus, a minus, or a divide, then it would be those. But because it isn't, we automatically turn it into multiplication. The same way that if we have negative 5 with a parentheses, we would automatically multiply to the parentheses, okay? All right, so remember, we still begin with what's inside the absolute value sign. 3 minus 7 gives me negative 4. I keep my signs. I bring down my negative 5 and my multiplication sign. Now, negative 4 with the absolute value becomes positive 4. I do not have to bring down the absolute value anymore because I already applied it and I made things positive, but I do bring down my negative 5 and I still multiply it, okay? And now, negative 5 times 4 gives me negative 20. And that's it. That's my final answer. Okay, I hope that made sense. Once again, we work on what's inside the absolute value sign first. We keep bringing it down until we're done simplifying, okay? All right, let's do the next one. So the next one looks pretty straightforward. I like rewriting them because sometimes, well, especially now that I'm showing you this, it's a little harder to see. 2 plus 4 is 6, positive 6, and that stays as just positive 6. So that one was really straightforward, right? Okay, let's move on to the next one. Negative 5 plus 13 gives me a positive 8, and it stays as positive 8 with the absolute value sign. There we go. All right, let's keep going. It looks like we're taking a break from the hard ones. And never mind, I spoke too soon. Here we go. So here they get more complicated again. Remember, the first thing we do is absolute value. So I'm going to rewrite this over here so it's just easier to see. Remember, when we don't have a plus, a minus, or a division between a number and an absolute value, this becomes a multiplication. So I'm going to put that out there to remind me to multiply. So now that I've done that, I start with what's inside the parentheses. Negative 3 plus 8. That gives me positive 5. I keep my absolute values, and I keep this out here. Positive 5, when we apply the absolute value, just stays as a positive. So I bring down everything else. I do not have to write the absolute value sign this time. I can take it away because I've already applied it. And now here, the order to do things we take from PEMDAS. PEMDAS, remember, stands for parentheses, exponent, multiplication, so it's an acronym, right? Division, addition, and subtraction. Okay, so we handle the parentheses first, and here our absolute value sign is considered like a parentheses, so we did that. Exponents, we don't have any. What's next? Multiplication. So we do the multiplication first. 3 plus 2 times 5 is 10. And now the only thing left, because there's no division, is just adding, so this gives me positive 13. So always write down PEMDAS so it reminds you what order to do the math in, okay? If we would have done 3 plus 2 is 5, and 5 times 5 is 25, that would have given us a different answer, and it would have been the wrong answer. So make sure that you do things in order. Okay, remember, you can always go back and rewatch these explanations. They are for you to use them to work through this. All right, let's do another question. So negative 12 plus absolute value 6 minus 7. So here it does have a sign, so we don't have to multiply. We keep our sign, okay? Now, we start with absolute value. Why? Because that's my parentheses. Let me just put that there so you remember. So 6 minus 7 gives me negative 1. I bring down my absolute value, and I bring down my negative 12 plus. The negative 1, when we apply the absolute value, becomes positive 1, and I don't have to bring down the absolute value signs anymore because I already applied them. And now negative 12 plus 1 gives me negative 11. And that's it. Okay, that one was a little easier. Let's keep going. Number 13. So here it does show me the signs. 5 times 3 minus 2 minus 9. So first thing first, actually let me write the PEMDAS up here so I don't forget the order. We start with the absolute value. 2 minus 9 gives me negative 7. I keep my absolute value signs. I bring down the rest of it. Negative 7, when I apply the absolute value, becomes positive 7. I bring down the rest of it. And now I have multiply and subtract. So I'm going to use my PEMDAS to be able to tell what comes first. Parentheses, exponents, multiplication. So I multiply first. 5 times 3 is 15. I bring down my minus 7. There's no division, no addition. Subtract is my final step. 15 minus 7 is positive 8. And that is my final answer. Okay. Here we go. We got a couple left. Let's keep going. Number 14. Negative 11 plus 8 gives me negative 3. When I apply the absolute value, it gives me positive 3. So these got a little more simple. Okay. And then last but not least, absolute value 15 minus 32. 15 minus 32 gives me 17. Sorry, negative 17. I apply my absolute value and it gives me positive 17. And there we go. All right, that is all of our questions for the absolute value quiz. I hope this made sense. I hope this helped. Remember, if you still have any questions, feel free to leave a comment below. Okay, keep going. You're doing a great job. Hi, this is Natalia again from ASVAB Success. In this video, I want to talk to you about factorials. So if you're ready, let's get started. Okay, so like I said, this video is about factorials, and factorials are essentially a number with an exclamation point behind it. Now, I know it looks funky, but it's actually really easy to solve. So I just want to show you what it is so that when you find it, you're not freaked out by it and you know how to solve it. So what do we do when we have this exclamation point behind? What we do is we're going to multiply all the numbers that come before this number counting, including this number. That sounds funky, but basically it looks like this. 1 times 2 times 3. We stop at the number itself. We start with number 1 and we go all the way to the number itself. So 1 times 2 times 3. We multiply them together. 1 times 2 is 2. 2 times 3 is 6. So this multiplies to give me 6. In the same way, if I have, for example, 5 factorial, okay, I'm going to do 1 times 2 times 3 times 4 times 5. Okay. Now this one's a little bit longer, so I'm going to group it. 20, 6, and then just like 1. 1 times 6 is 6. 6 times 20 is 120. So 5 factorial gives me 120. All right. So like you saw in this one, I kind of grouped together the numbers to make the multiplying a little more easy for me. You're more than welcome to do the same thing. If you have another way that you want to multiply these together, you're welcome to do so. Let's look at another example. This example is interesting because it's just 2. So what does this look like? 1 times 2. Same thing if we have 1 factorial, it would just be 1. Okay. Now, last example, I want you to give this one a try. So pause the video right now, try this one out, and when you're ready, just hit play again because I'm going to show you how to do this one now. So this is 1, 2, 3, 4. Once again, I group. 2 times 12 gives me 24. It doesn't matter how you multiplied it as long as you get 24 at the end, okay? So like you can see here, factorials is pretty easy. There's just one thing we can do to this to level it up or make it a little more challenging. So I want to show you that example next. And that looks like this, okay? When we have an example like this, what we want to do is solve for each factorial separately and then add them together. If it's subtracting, multiplying, dividing, whatever, you want to solve the factorials and then you want to perform the operation, right? Let's see what this looks like. 2 is 1 times 2. So that gives me 2. That's easy, right? Plus 4 factorial. 1, 2, 3, 4. That's 12 plus 2 plus 1. That gives me 24. Now that I have solved the factorials, now I can add them together. 2 plus 24 gives me 26. All right. So now that we've seen these examples, you have plenty of practice below in the quiz. Go ahead and do that quiz. And remember, if you have any questions, feel free to leave me a comment below. Okay, good luck. Keep working hard for that ASVAB. Hi, welcome back. This is Natalia from ASVAB Success. And in this video, I want to talk to you about square roots. So if you're ready, let's get started. Before we can talk about square roots, we need to talk about squares or squared numbers. When it says a squared number, what that really means is that we're multiplying a number by itself. So 2 times 2 is a squared number. This is also written as 2 squared, okay? The little exponent, when we have that small number up here, this is called an exponent. When we have an exponent of 2, this is called squared, okay? So 2 squared, or 2 times 2, gives me 4. 3 squared, or 3 times 3, gives me 9. 4 squared, or 4 times 4, gives me 16. And yes, I am going to go through a long list of them. It's important that you memorize these. 5 times 5, or 5 squared, is equal to 25. 6 times 6, or 6 squared, is equal to 36. 7 times 7, or 7 squared, is equal to 49. 8 times 8, or 8 squared, is equal to 64. 9 times 9, 9 squared, is 81. 10 times 10, 10 squared, is 100. I recommend you keep multiplying like you memorize. All the way, let's get to 12 squared, to 12 squared. If you want to memorize 13, it's also recommended. I wouldn't go past 15. But you want to write these down and you want to memorize them. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. You want to memorize what the number squared is and the actual, like, the product, okay? So you want to memorize these. Why is this so important? Because remember, this video is about square roots. Square roots are the opposite of squared numbers. So if a squared number is 2 squared equals 4, okay, we go in this direction. A square root of 4 equals 2 takes us back in the other direction. So square root means we start here and we want to move back to the original number that was multiplied, okay? I know it's a little funky, but it is what it is, all right? So if I know, I'm going to give you a couple of examples. 3 squared equals 9. The square root of 9 is equal to 3. Why? Because we're going backwards. When I have a square root, I'm asking myself, what times what gives me this number? They have to be the same, right? What times what equals this number? So 4 squared is 16, which means the square root of 16 is 4. So when we write square root, it's this like lightning looking little like house on top of the number, okay? Square root. Square root. All right. So I'm going to give you a couple more examples. 5 squared equals 25. So the square root of 25 is 5. Okay. I hope this is making sense. So now that we understand where square roots come from, right? It's going backwards on a squared number. Let's take a look at simplifying some of them. When you get a square root question on the ASVAB, there's 2 different kinds of questions that you can get. You can get something like this. Simplify square root of 64. Okay. If that's what you got, then what you need to do is figure out what number do I square to give me 64. So a couple things. Number 1. I know 10 squared is 100. So right off the bat, sorry, I just realized you can't see that. Let me try it again. 10 squared is 100, okay? So right off the bat, I know that it's going to be less than 10 because 10 squared is 100, 100 is too big. So I can try 5 squared halfway through. That's 25. So it's going to be bigger than 5, but less than 10. So I go with the other numbers. 6 squared, 36. 7 squared, 49. 8 squared, 64. If it's weird for you and you're still not comfortable with the squared, then just do 5 times 5. Oh, that's 25. 8 times 8. Okay, that's 64. All right? If that's what is more comfortable for you until you get comfortable with the squares. So by doing this, I realized that 8 times 8 is 64, which means that the square root of 64 is 8. And that's it. So these are easy because these are called perfect squares. That means we're taking the square root of something that has an exact number that's a square. Okay? So for example, if we have another question that says simplify square root of 81, okay? Then I say, okay, that's pretty close to 100, and I know that 10 squared gives me 100. So let me go a little bit lower. 9 squared, 9 times 9, that's 81. There we go. So the square root of 81 is equal to 9. This is, again, called a perfect square. Why? Because a whole number is squared to give us that number. All right, so I'm going to give you one more example. I'm going to ask you to pause so you can try it on your own. All right, let's draw a line there so we don't get confused. Actually, let me just do that. Simplify square root of 36. This is a good time to pause and try to find the answer on your own. If you have the answer, then let's go ahead and do it. I remember that 5 squared is 25. It's a little bit below 36, so I'm going to try 6 squared, which is just 6 times 6, and that gives me 36. So this is equal to 6. And that's it. All right. So now that we got squares, square roots, and perfect squares, let's talk about the second kind of question that can happen on the ASVAB with square roots. And that is with numbers that are not perfect squares. So when we have a number that's not a perfect square, what we want to do is we want to factor what's inside the square root. What does that mean? That means that I'm going to look for the factors. Factors are the numbers that multiply together to give us a number. So for example, here, our question is 50. We can do 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. There's no perfect square that gives us 50. Okay, that sucks. What do we do now? Now we know that this is not a perfect square, so we have to factor. What are factors? Factors, like I said before, are the numbers that multiply to equal this product, or this number. The factors of 50 are 1 times 50 gives me 50. 2 times 25 gives me 50. 5 times 10 gives me 50. These are all the factors that multiply together to give me 50. So now, what do? Step number 2 is to look for perfect squares within the factors. So for example, 25 is a perfect square. 5 times 5 equals 25. So what I do, I'm going to take this, and I'm going to use that. So the square root of 50, let me fix this a little bit. The square root of 50 becomes the square root of the factors, 2 times 25. Okay? Now that we have 2 times 25, I'm going to separate them, square root of 2 times the square root of 25. I'm going to separate them into separate square roots. Once I do that, I'm going to simplify by taking the square root of this one right here, because that's a perfect square. So square root of 2 times the square root of 25, we know, is 5. So my answer is square root of 2 times 5. The correct way of writing this is to put the whole number in the front and put the square root behind it. So my answer here is 5 root 2. And that's it. All right, so I want to give you one more example that I'm going to do with you, and then I want to give you one that you're going to do on your own. All right, so let's look at another example. Simplify square root of 200. Now, 200, I know, is 1 times 200 and 2 times 100. Check this out. 100 is a perfect square, right? I know that 10 times 10 equals 100. That is a perfect square. So I'm going to use this set of factors to be able to multiply and simplify this, okay? So this becomes square root of 2 times 100. Then I separate them. Square root of 2 times the square root of 100. And now that I do that, now that this one is by itself, I take the square root of it. Square root of 2 times the square root of 100 is 10. And because I'm a scholar and so are you and we like to do things correctly, we put the whole number in the front and the square root behind it. So our final answer here is 10 square root of 2. All right. So now that I've shown you the second example, remember, if you need to pause, go back, take a look at it again. This is a video. You have the liberty of doing that. But if you're ready, let's go ahead and look at the next. So I want you to try this one on your own. This one says simplify square root of 45. I'm going to bring this a little lower. All right. So this is not a perfect square, which means you have to go ahead and factor. So give this one a try. You can hit pause right now. But if you're ready, let's go ahead and review it. What are the factors of 45? 1 times 45, 3 times 15, and 5 times 9. Out of these, the 9 is the only perfect square, which means ding, ding, ding. This is going to be the set. Sorry, this is going to be the set of factors that we use. So square root of 45 is going to become square root of 5 times 9. Then it becomes the square root of 5 times the square root of 9, because we want to break it down even further. And now that we do that, square root of 5 stays the same. We're going to take the square root of 9 to simplify, but we get times 3. And because we're scholars, we're going to switch it around so that the whole number goes in the front, because that's the appropriate way of writing it. So the whole number goes in the front, and the square root goes behind it. 3 square root of 5. And that is it. All right? So that's it for this video. It's not too hard, but it's definitely challenging, so take your time with it. You have a quiz below, so go ahead and keep practicing this. And as always, if you have any questions, please feel free to leave a comment below. Hi, this is Natalia with ASVAB Success, and in this video, I want to review the quiz questions from the square roots lesson. So if you struggle with this lesson, that's okay. I want to walk you through a couple of these questions. So let's start from the beginning. Remember that a square root is basically going backwards from a squared number. So we have 3 times 3. This is a squared number, 3 squared, because we multiply a number by itself, and 3 times 3 gives me 9. A square root is going in the opposite direction, and finding out what the original number that multiplied by itself to give me that number. Okay, so with that said, when I see the square root of 25, I know that 5 times 5 gives me 25. These are both the same number, so the square root of 25 is 5. All right, let's keep going. Same thing goes with number 2. 11 times 11 gives me 121. So the square root of 121 is 11. All right, I hope this is making sense. Let's look at another example. 100. 10 times 10 gives me 100. So the square root of 100 is 10. 169. I know these are larger numbers, but if you remember in the video, I challenged you to memorize the squared numbers all the way to 15 squared, which is 225. So here, this is 13 times 13. That's 169. So here, we have this. Now, let's say you can't remember that. You want to first start off with a square that is close to 169. Let's say 100, okay? 10 squared is 100. You can keep going. So you go 100. Oh, this is 121. This is 144. Until you get to 169. So that's another way of going about when you get a larger number and you can't remember it. But remember, it's a good idea to memorize your squares. Okay, let's keep going. So here with 200, we don't have anything that's exact because 14 squared and 15 squared, this gives me 225. 14 squared, 14 squared is 196. Okay, and this just doesn't work. So there's no exact square for 200. So what am I going to do here? This means that I need to break down the number by factors. Well, 2 times 100 gives me 200. And 100 is a squared number. So this works. So the way I'm going to do this is the square root of 200, which is the square root of 2 times 100. I can separate them, square root of 2 times the square root of 100. The square root of 2 stays just like that. All I did was separate them, okay? The square root of 2 stays just like that. The square root of 100 can be simplified to 10. So square root of 2 times 10. And when we write square roots, the whole number goes in the front. So 10 times the square root of 2. And that's it. So what I did here is I wrote the number. I broke it down into factors with a factor that has a perfect square. Then I separated them. The square root of 2 stays here. And then I took the square root of the squareable number. I don't know if squareable is a word, but you know what I mean. So here my final answer is 10 root 2. Okay, let's take a look at the next example. So this example here, square root of 45. I know that 6 squared gives me 36. 7 squared equals 49. So that tells me that there's no whole number that will square to equal 45. So once again, what I need to do is break this down into factors to simplify it. So 45. Let's break down the factors. We have 1 times 45, 3 times 15, 5 times 9. When I look at this, I see one of them that has a perfect square. 9 is a perfect square. 3 times 3 is 9. So this is the one I'm going to use. So I'm going to rewrite this now. Square root of 45 is the same thing as square root of 5 times 9. Now I'm going to separate them. Square root of 5 times the square root of 9. The square root of 5 stays the same. I can't simplify that anymore. But the square root of 9 can be simplified. It's a 3. So now that I have this, I bring my whole number in the front, and my root stays there. My final answer is 3 root 5. Okay? I hope this is making sense. I encourage you to give it a try on your own as well. That's always a good idea. If you're ready, let's keep going and look at the next example. So here, this says simplify square root of 9 plus the square root of 16. So the square root of 9, I'm going to rewrite it over here. The square root of 9 is 3. The square root of 16 is 4. 3 plus 4 gives me 7. So that one was pretty easy because they are perfect squares. Okay? You do not have to bring them together. 9 plus 16, you don't do that when we're adding. You just find the square root of each one. Okay? Number 8, square root of 50. So here, if we remember, 7 squared is 49. 8 squared is 64. So there's no whole number that will square to give me 50. So this tells me, okay, I need to break this down and simplify it. So 50 is 1 times 50, 2 times 25, and 5 times 10. Here, the 25 is a squared number. It's 5 squared. So I'm going to use this one. Okay? So square root of 50, let's start breaking it down. Square root of 50 is the same thing as square root of 2 times 25. I'm going to separate them. Square root of 2 times square root of 25. And square root of 2 stays like that. Square root of 25 is 5. I bring the whole number in the front, and my final answer is 5 times square root of 2, or 5 root 2. Okay, let's keep going. This is a similar question where we have to break it down. If you want to pause here and try this, if you didn't get it before, this is a great time to do it just to practice. Okay, if you're ready, let's review it. So once again, 7 squared is 49. 6 squared is 36. This falls in between, so there's no whole number. So we simplify it. Well, 48 has a couple of them. 1 times 48, 2 times 24, 3 times 16, 4 times 8. Not 4 times 8, sorry. Whew. 6 times 8. There we go. Okay, I'm like, that's not true. 4 times 12. That's what I was missing. Okay, so here, if you notice, we have 2 of them, 1, 2, that are perfect squares. 16 is a perfect square, and 4 is a perfect square. So what you want to do is you want to choose the bigger number. Okay, so here we go. Square root of 48 is the same thing as square root of 3 times 16, which we can separate. And now, square root of 3 stays the same, and square root of 16 is 4. I bring the whole number in the front, and I get 4 square root of 3. And there we are. Okay, so if you have a number that has more than one square as a factor, always pick the bigger square. That's our lesson here, okay? Let's go ahead and make some space and move on to the next one. Square root of 36, this one's easy. This is just 6 squared equals 36. Keep going. Square root of 144, 12 squared equals 144, so it's 12. Let's look at number 12 here. Square root of 36 and square root of 64. These are perfect squares, so we just have to simplify them. Square root of 36 is 6, plus square root of 64 is 8, and 6 plus 8 gives me 14. So that one's pretty straightforward as well. Let's keep going. Square root of 225, remember, we're memorizing all the way up to 15, so 15 squared gives me 225, so here my answer is 15. Let's keep going. Square root of 100, minus the square root of 36. Square root of 100 is 10, square root of 36 is 6, 10 minus 6 gives me 4. So these again, remember, we're not subtracting what's inside of the square root. We find the square root and then we subtract, okay? And then last but not least, the square root of 1 is just 1, because 1 times 1 equals 1. So there we are. Okay, great job. I hope this is making more sense. Remember, you can always go back and rewatch any of the questions that don't make sense. And if you have any questions, feel free to leave a comment below.